All right, so now we are diagramming in the traditional square. And this is the very first video I showed you this argument where it's like, it was still valid, but the pictures didn't match up exactly. That's because of how we diagram in the traditional square. These are the cases where we're going to have valid arguments, but the diagrams are not going to be perfectly identical. Because remember, we are assuming the existence, and this pertains specifically for A and E statements. When we diagram under the traditional square, O and I statements, they're diagrammed the exact same, but it's the E and the A statements that we have to make a slight difference. We have to assume some existence. So check this one out. All dogs are friendly creatures, therefore some dogs are friendly creatures. Remember, under the modern interpretation, this was invalid, even though when we're looking at the semantics, it seems valid. Like, how could it be the case that all dogs are friendly creatures is true, but some dogs are friendly creatures is false? That just seems like it doesn't seem possible. So this was a flaw of the modern interpretation. Traditional interpretation fixes it. We can say that this argument is now valid because we change how we diagram A and E statements. So normally with an A statement, we shade in that left-hand side, but we don't draw any X anywhere because we're not assuming existence. Now we shade in that left-hand side and we draw an X with a circle around it in the middle to represent some assumed existence. So when you have the statement, all dogs are friendly creatures, we're going to shade it because we're still saying that there's nothing that exists that's a dog but not a friendly creature. And then we're going to draw this X with a circle to represent the existence of at least one dog who's also friendly. Same thing for our E statement. So a normal E statement, we shade that middle part because no S or P, saying that there's nothing that's an S and also a P. But under the modern interpretation, that's all we do. We don't draw any X's because we're not assuming existence. Traditional interpretation, we draw two X's with circles around them. One in our S but not P section, and one in our P but not S section. And those X's are representing some assumed existence. That, sure, no dogs are pilots, but we're going to assume that there's some dogs that exist, and we're going to assume that there's a pilot that exists. Because traditional interpretation, we are assuming existence. When we have an argument like this, all dogs are friendly, some dogs are friendly, we see that they're provisionally valid. And what does that mean? It means looking at the syntax alone, this argument is provisionally valid. Like, where it's almost valid, but we got to do one more step to determine whether it's truly valid. And why is this provisionally valid? Notice they don't look the same, but we have an X in our conclusion here in the middle, and we look and see that, hey, there's an X in our premise. There's other information in our premise, namely this shaded area. This premise is telling us more than our conclusion is telling us, but the conclusion is still contained in the premise, despite the fact that these diagrams are not exactly identical. So don't use that rule where if they're identical, they're valid. If they're not identical, they're not valid, because of cases like this. Under the traditional interpretation, the diagrams are not going to match up, but we will have a case where conclusion is contained in the premise, so provisionally valid. So I said provisionally valid, it's like one step closer to valid, but not fully valid yet. How do we get to full validity? So this is just outlining what I'm just saying. We look at the conclusion, we see there's an X somewhere in the diagram, and then we look to see if that X is in the same spot in the premise for the argument to be valid. If there's a shaded area in the conclusion, then the premise needs to have that shaded area as well in the exact same spot. Here, we have an X in our conclusion, and we also have that X in the premise, even though the premise has additional information. And notice the pictures are not identical. The step to figure out whether this argument is truly valid is to consider existence. And in this argument, I'm using the predicate, all right, I was talking about friendly, but also the mammals one works too. Do dogs exist? Yes. Do mammals exist? Yes. Or in this case, friendly creatures. Do friendly creatures exist? Yes. All of these, the subject, this predicate, they all actually exist in the real world. So the argument is valid. But consider this argument. All unicorns are creatures with horns. Therefore, some unicorns are creatures with horns. It's going to be the same diagram. It's going to look like this. All unicorns are creatures with horns. Some unicorns are creatures with horns. So this argument is going to be provisionally valid. But when we look to see whether our subject and our predicate class actually exist, we notice that unicorns don't exist. So this argument is considered provisionally valid, but it's not actually valid. Why? Because unicorns don't actually exist. So a virtue of the modern interpretation is that we're just doing pure syntax. We're not doing any semantics when we're working underneath the modern interpretation. But the con of the modern interpretation is that some arguments that we feel are valid are not valid. We can't say that they're valid under the modern interpretation. Now, a virtue of the traditional interpretation is that those arguments that we feel are valid are now valid. We can give an argument as to why they're valid. Why? Because we're assuming existence. But a con of the traditional interpretation is that now we have to analyze semantics to find out about validity. And validity is supposed to be a purely syntactical concept that we don't have to worry about messy semantics when we're evaluating validity. All we're evaluating is the structure of the argument. So under this traditional interpretation, we lose the very essence of validity, which is pure syntax, because now we have to go analyze semantics. We have to go out and look in the world and see if they're dogs and see if they're mammals and see if they're friendly creatures and see if they're unicorns in order to figure out whether our arguments are valid or invalid. So no interpretation is better than any other one. There are significant differences, and you'll need to know those differences in order to do well on the next quiz.